So welcome to the third lecture of linear algebra, Math 120, in fact. If you have any question regarding the previous lectures, you can ask me. Let's start now today's lecture. Today we are going to discuss equivalent linear systems. Equivalent linear systems. Let's start with the help of an example. If we have a 3x3 or 2x2 system of this kind, for example, example, x plus y plus 2z is equal to 9, 2x plus 4y minus 3z is equal to 1, 3x plus 6y minus 5z is equal to 0. So this is a given linear system. How can we solve it? By using simultaneous method. I hope you know how to solve equations simultaneously. What operations we can apply on this linear system in order to solve it simultaneously? Means we make a coefficient of one variable same, identical, and then we cross it and so on. What operations, if we call it, for example, equation 1, equation 2, and equation 3. What operations we can apply on this linear system in order to solve it simultaneously? For example, the first operation is that we can interchange any two rows. Would there be any effect on that linear system?
Yes, sir.
What effect?
So it will be easier to solve it, the equivalent linear system, if we interchange the row.
Not row, equations. We are talking about equations. In order to solve any linear system simultaneously, there are certain operations which do not change the solution of the linear system if we try to solve them. For example,
Yes,
we can interchange any two rows, interchange any two equations. Interchange any two equations. This will not affect the solution of a linear system. The resulting linear system which we obtain will definitely have same solution as the original linear system. So this operation doesn't change anything in the linear system. The solution would remain same. Okay, after applying this operation, we say that the resulting system, the resulting linear system is equivalent to the original linear system. Because why we call them equivalent? Because they have same set of solution. The solution would not change in this case. So this operation is allowed. For example, we say that interchange, how do we write it? Equation 1, interchange it with equation, for example, 2. How do we write it? E1 and this sign, E2. It means interchange first equation with the second equation in the previous linear system and obtain a new linear system. This is how we can do this. The second operation which is allowed in order to solve the given linear system simultaneously, and it doesn't change anything, multiply an equation through by a constant. This is also an operation which we can apply on any equation. What does it mean? We can multiply any equation on both sides by any constant. And how do we write it? For example, we are going to multiply equation alpha, equation 3 by alpha. Okay. And how do we write? Alpha is some constant. Can we mute your mics? काइंडली म्यूट योर माइक, किसी का माइक ऑन है काइंडली। किसी भी इक्वेशन को किसी कांस्टेंट से मल्टीप्लाई कर दें, इट डजंट चेंज एनीथिंग दोनों साइड्स पे। So this is another operation which we can apply on these equations in order to solve them simultaneously, and the resulting system will be equivalent to original system. Okay, the solutions of both these systems will definitely be same. Third operation which is allowed in solving this equation is that add or subtract a multiple, a constant multiple, you can say that, a constant multiple of an equation of any, of an equation, ठीक है, of an equation into any other equation. What does this mean? That in order to solve this linear system, what we can do, we can multiply, for example, equation 1 by 2 on both sides, and then subtract from equation 2. Then the x, the coefficient of x, will be eliminated. So this is how we solve them simultaneously. So this kind of operation is also allowed, and the resulting linear system will be equivalent to the original linear system. Means both linear system must have same set of solutions. So how do we write it? We write it in a way, multiply some equation, for example, equation 1, and subtract it from equation 2.
Set to bring you on campus. जुमे को 22 तारीख को अगर कोई ईमेल कर दे तो शाम को आ जाती है, तो आपको इतवार को तो हमने सब हफ्ते को सब बता दिया, इतवार को मुलाकात कर ली, ठीक है? इससे ज्यादा जल्दी
माइक ऑन है किसी का, काइंडली म्यूट योर माइक्स। सो अगर हमने इक्वेशन 1 को x को एलिमिनेट करना है यहाँ पे, तो हम क्या करेंगे, इक्वेशन 1 को -2 से मल्टीप्लाई करेंगे और ऐड कर दें इक्वेशन 2 में, ठीक है? सो यहाँ पे जो चेंज होगी इक्वेशन, वो कौन सी होगी, इक्वेशन 2, और यू कैन राइट इट इक्वेशन 2 minus alpha times E1. Okay, the equation which will be changed will be the equation 2. But I would prefer कि आप ये notation use करें पहले वाली, so that कि आपके पास जो second equation है वो हमेशा change होगी, first वाली equation change नहीं होगी. So these are three elementary operations which we can apply on this linear system in order to solve it simultaneously. जी बेटा बोलें, any question?
Sir, the question is कि आपने कहा कि ये पहली वाली नोटेशन इस्तेमाल करें। सर अगर हम दूसरी वाली नोटेशन इस्तेमाल करते हैं तो इसके कॉन्सिक्वेंसेस में क्या हम कंफ्यूज होंगे?
You can do it if you are comfortable with the second.
सर आंसर में ड्राइव करने में तो कोई प्रॉब्लम नहीं होगी?
नहीं, I don't think so. But this notation is usually used in the books. Okay? So you would not be confused with the book solution and your solution. Okay?
Okay, sir.
First one. Now, जी बेटा बोले.
The third point है, could you repeat this? It's a constant multiple of an equation add करना है.
What would you do here in order to eliminate x in equation 1 and 2? What will you do here? Can you see this?
Yes, sir.
No, that girl who was talking.
Yeah, sir.
What you do here in order to eliminate x from these two equations? What you do?
We multiply x by 2 in the above equation, तो फिर हम माइनस करके कर सकते हैं.
हाँ, यही किया ना हमने. क्या लिखा है यहाँ पे? -2 times equation 1 plus equation 2.
सही.
ठीक है, ये लिखा हुआ है ना. So what operation do you need here? -2 times equation 1 plus equation 2. What will be changed? Equation 2 will be changed. जिस इक्वेशन का कांस्टेंट मल्टीपल आप ले रहे हो ना, वो चेंज नहीं हो रही. जिसमें ऐड कर रहे हो वो वाली इक्वेशन चेंज होगी बेसिकली.
Sir, it gives rise. It like I have another question now.
Yes.
We are like multiplying it with -2. We can
Hmm.
like also do it the other way around, like multiplying with 1/2 to make it 1.
Yes, you can multiply equation 2 by 1/2, but then in that case you have to add it in equation 1.
Yes, sir.
ठीक है.
Yes,
So
sir.
जिस इक्वेशन का मल्टीपल ले रहे हैं ना आप, उसको किसी दूसरी इक्वेशन में ऐड करना है. This is what we have
No,
written
no,
in
no,
the
no,
third case.
no. Sir, I'm saying instead of using this third rule of equivalent linear system, I'm talking
Yes.
about the second rule of multiplying equation by a constant. Like I'm
Yes.
multiplying the second equation with 1/2, which will make it x.
Yes, it will make it x. Okay, you can do it. But in the next time, then you can subtract equation 1 from equation 2 in order to
In order
eliminate
to-
the x.
Okay, sir. Okay.
Okay? Then you have
Got it.
you would definitely need 2 operations in order to eliminate x from the second equation.
Excuse
Yeah.
me, sir.
जी बेटा.
For the third part, is it so that after we have a new equation 2, so in the new linear system, it will be a different equation 2, but the same equation 1 and equation 3?
Yes. Equation 2 will be changed, but the equation 1 and 3 will remain same.
All right. And sir, what do we mean when we say that we're going to interchange two equations? Are we just going to flip their positions?
Yeah. Yes. Flip their positions.
So now 2x plus 4y will be on top and x plus y will be below it,
Yes.
right?
Yes, in the center.
Thank you.
Now, we basically, whenever you try to solve a linear system in 2 by 2 variables, it is very easy to solve that system simultaneously. Okay, you know how to do it. But when the linear systems, they get bigger, they have more unknowns and more equations, it is very difficult to solve them simultaneously. So we need to devise some procedure, some method in order to solve them easily or technically. Let's write again that system. X plus y plus 2z is equal to 9. 2x plus 4y minus 3z is equal to 1. 3x plus 6y minus 5z is equal to 0. Now, I'm going to write here its equivalent augmented matrix. I told you already what is augmented matrix. बताया था मैंने?
No, sir. No, sir. अभी इस पे discussion नहीं हुई.
So now we are going to write augmented matrix. Augmented matrix is basically a matrix of the form. You try to write the coefficient matrix of this linear system 1, 1, 2, and then right hand side number 9. The 2, 4, minus 3, and then 1, 3, 6, minus 5, and 0. So this is the augmented matrix. How do we write it?
Sir?
We write the coefficient matrix here and the right hand side vector also in the rightmost column of that matrix. जी बोले.
Sir.
Sir,
Okay, sir. Abdul Ahad, please.
जी बोले.
अब सर वो मेरा क्वेश्चन आंसर हो गया वो I was confused for a second.
Okay.
Sir, my question is that in the notes which you have provided us on LMS, sir, ये जो line है, this particular line is not drawn over there. So if we don't draw this line, or if we draw this line, will it be any different?
It doesn't change anything. I just draw here a line in order to differentiate between the coefficient matrix and the right hand side vector. If you don't want to draw it, you just be sure that this rightmost column is the right hand side. Okay?
Okay, sir.
If you say that this is augmented matrix, it is obvious that the rightmost column is the right hand side of that linear system.
Yes, sir.
Okay? If we say augmented matrix. If you say it's only matrix, then we are not sure that the rightmost column corresponds to a linear system. Okay?
Okay.
In in augmented matrix, the rightmost column is basically the right-hand side of the linear system. That is why we call it augmented matrix, in order to differentiate from other simple or usual matrices. Okay?
Sir, for the augmented matrix, is it important that all the unknowns must be on the left-hand side? What if we move, for example, in the first equation, 2z to the right-hand side? So
no, they should be on the left-hand side.
So the right-hand side, it must be just one column, right?
Yes.
The far right column. Yeah. Okay.
Yes.
Thank you.
The rightmost column in the augmented matrix must be the right-hand side of the corresponding linear system. Okay. Now, the operations which you have applied there, E1, जो कि हमने वहाँ पे कहा था, you can say it EI interchange with EJ. EJ means कोई भी रो आप कोई भी इक्वेशन किसी दूसरी इक्वेशन के साथ इंटरचेंज कर सकते हैं. I represents any equation for, you can say that I is from 1 to 3 क्योंकि ये 3x3 system है. This was the first operation. Second operation was you can multiply any equation EI by some constant, whether it is positive or negative, it doesn't matter. The third operation is a constant multiple of any equation can be added into some other equation. This was the third operation which was allowed and the equation which will be changed will be the EJ. So these three operations, they do not change anything in the linear system. Anything means they're solutions. Okay? If we apply these three operations on any linear system, they will not change the solution of the given original linear system. Ji, bole.
Like you are multiplying with a constant in the third equation, which is EI, with a constant plus EJ, which makes EJ. If I don't want to make the second equation change, I want to make the first equation change. So will I make it the constant EI plus EJ is equal to EI?
I don't get your point. Can you please repeat it?
Sir,
if you want to change?
Sir, if I want to change the first row, the first equation, instead of the second equation, which you have represented by EJ, so will I make it EI?
You cannot multiply an equation, the same equation, with a constant, some constant, and add into the same equation. This is not possible.
Okay.
You have to multiply an equation by a constant and add or subtract it from some other equation. In this case, equations cannot be same. They should be different. I should not be equal to J. In that case, and also in this case as well, I should not be equal to J.
Okay, so that's not equal to J, but what I am able to grasp from what you're saying is that if I'm multiplying any constant with the first equation, I can't add that and like add my entire result into that first equation. I have to add that into another equation, whether it's second, third, or any.
Yes.
Okay, sir.
Same for all the buses.
Sir, in the first part where you said कि हम interchange कर सकते हैं, so how does that help us in eliminating?
I'll show you. Wait for 10 minutes. Okay.
All right.
Now, these were operations for equations in order to solve them simultaneously. Now we have converted this linear system into a matrix. Main thing which is going to change is basically the coefficient of the unknowns. Okay. Now we are going to apply all these operations on this augmented matrix, but in the form of row operations. Now we are going to call them row operations. Okay. These were the operations on equations. Now we are going to define elementary row operations. And these operations are usually basically applied on that augmented matrix. The first operation which is allowed is what? The similar. Now here we have had equation, now we have rows. So we can say that row I can be interchanged to some row J, where I is not equal to J and I, J are basically I is equal to either 1 to 3, J is equal to 1, 2, 3. Okay. Now this is the first row operation which is allowed in order to solve that linear system by using this augmented matrix. This is the first operation, row operation. The second row operation, which is allowed, that we can multiply any row with some constant. Okay. The third operation, which we call elementary row operation, is that we can multiply a row by a constant and add it to some other row. And which row will be changed? The row J. Okay. So these are elementary row operations, 3 operations, which we are going to solve that linear system, in fact, using this augmented matrix. Okay. Now, how to solve them now simultaneously? We are now going to use these elementary row operations in order to solve this, in order to simplify this augmented matrix so that we can solve the given original linear system. Okay.
Okay, sir.
So now let me write again that augmented matrix on the other board. Let's try second board so that I can see the matrix. Now, the matrix is 1, 1, 2, 9, 2, 4, minus 3, 1, 3, 6, minus 5, 0. This one. Now, how do you solve it systematically? Try to make.
Can I suggest?
Yes.
So we will multiply the first equation or the first row with the constant -3 and add that with the third row or the third equation to make the third one 0.
Okay.
And eliminate X.
Let me explain you the procedure, how to do it. In any augmented matrix, in order to solve it simultaneously, the original linear system, try to make 1 here. Okay. The first entry, you try to make it 1. So fortunately, this is already 1. So we don't need to make it 1. If it is other than 1, you can divide the first row with the same constant in order to get the first entry as 1. Okay, so this should be your first operation. The second operation, which you should, यहाँ पे अब क्या operation होगा? कुछ भी नहीं, क्योंकि ये already 1 है. So it's okay. We don't need to apply any operation. Now, what you do next? The second operation, what you do, you try, after making 1 here, you try to make below it all the entries 0. Okay, you try to convert all the entries below this 1 into 0. Okay, how can we do this in order to make these 2 entries 0?
So we need to play with the first row or the first equation.
Yes. So what we are going to apply minus 2R1 plus R2. So this is the operation which I am going to apply in order to get 0 here in the first operation, in the first step. Okay. So this is your step 1, in fact, in order to solve it simultaneously. And this is your step 2. Okay. Now we are going to apply, we are going to basically make these entries 0. पहले ऑपरेशन में हमने ये ऑपरेशन लगाना, अब इसको हम अप्लाई करने लगे हैं इस पे. ठीक है. पहली इक्वेशन चेंज नहीं होगी. कौन सी इक्वेशन चेंज होगी? सिर्फ और सिर्फ second row change होगी. The first and third will remain same. First and third will remain same. You can write them before changing the second row. Now, first equation को आपने 2 से मल्टीप्लाई किया. ठीक है. यहाँ पे आप कर दें किसी डिफरेंट लेड पेंसिल से कर दें या किसी डिफरेंट 2 से मल्टीप्लाई कर दें. यहाँ पे और यहाँ पे 18 -2 से. यहाँ पे -2 आ जाएगा. यहाँ पे -2, यहाँ पे -2, यहाँ पे -18. And then you have to add them into the second row. So we get 0 here, we get 2 here, we get -5 here, and we get -17. Okay. Now, the next thing, what we need to do, we are going to make this entry 0. So what do we need here? -3R1 plus R3. What is going to change here? R3. So this operation will be what? In this case, only the row 3 will be changed. Row 1 will remain same. Row 2 will remain same. Row 3 will be changed. Now, I'm going to multiply this one with -3. We get -3, -3, -6, and -27. Now, we are going to add this into the third equation. What do we get here? 0. And then again?
3.
3. Okay. And then again?
-11.
-11. And then?
And -27.
-27. Okay. So this is the step 2. You have successfully made these two entries 0. The next step, the step 3 is what? Now you...
Excuse me, sir.
जी beta.
Sir, second row, third column, sir, -5 की जगह, sir, shouldn't be -7, I guess.
कौन सा? यहाँ पे?
Sir, second row.
यहाँ पे?
Yes, sir. Sir, -4, -3.
सर टॉप लेफ्ट पे वो -4 होना चाहिए।
सर वो -4 होना चाहिए।
जी हाँ, -4 होना चाहिए सर। ये
कहाँ पे? यहाँ पे?
सर
ऊपर टॉप पे।
यहाँ पे?
सर टॉप लेफ्ट मैट्रिक्स।
सर आप 2 से मल्टीप्लाई कर रहे हैं इक्वेशन 1 को, so the third column should be -4 in the new equation, not -2.
We are multiplying it by -2.
R1 by -2.
हाँ, -2 से मल्टीप्लाई किया, यहाँ पे -2, यहाँ पे -4 होना चाहिए। Yes. -4 होना चाहिए। Thank you. और then -4, -3, -7 आना चाहिए यहाँ। ठीक है? This is what you were talking about. I think it's -7. Okay. Now the step 3. In the step 3, what you do? आपने यहाँ पे 1 बनाया, यहाँ पे 0 और यहाँ पे 0. ठीक है? Now the next step in step 3, you have to make 1 here. In the second row, second entry को आपने 1 बनाना है। ठीक है? ये क्यों कर रहे हैं? I'll tell you after doing this. Okay? Now you are going to make this thing 1. So this entry should be equal to 1. You have to make it 1. How can you do that? Either you can divide this row 2 by 1/2. You'll have 1 there. Or you can have some other possibility. What is the other possibility? You subtract row 2 from row 3, you get 1 here, and then you can interchange them. Okay? So it depends on the situation. So what I'm going to do in the step 3, I'm going to use the simple one, 1/2 R2. Okay? Now, I'm going to make 1 here. Okay? अगर ये ऑपरेशन इस पे लगाएंगे तो what do we get here? Row 2 सिर्फ change होगी, row 1 and 3 will remain same. 0, 1, -7/2, -17/2. And then row 3 will remain same. Okay. This is your step 3. Now in step 4, what you do, you try to make 0 below this 1. You try to make 0 below this one by using any appropriate operation. How can we make 0 here? What operation can be used in order to make this thing 0? Anyone?
-3 R2 plus R3.
Yes, that's exactly the best operation which we can use to make this entry 0. So can I erase it?
Yes.
Let me write it somewhere here. यहाँ पे 1, 1, 2, 9. The entries are 1, 1, 2, 9, and 0, 1, -7/2, -27/2. ये था ना? 17/2. Sorry. 17 by 2.
And the last one is 0, 3, minus 11, minus 27.
Minus 11, minus 20. So now I'm going to negative 3R2 plus R3. So in this case, row 3 will be changed in this operation.
Sir, how did you manage to think that it should be row 2 and 3?
I'll tell you. Whenever, let me tell you this thing before applying that. Whenever you try to make 1 here in the first row and 0 below, you can only use this row in order to make these 2 entries 0. Not any other row, okay? You have to use this row where you have made 1. You can only use this row in order to make zeros below it. Now, in this step, you have made 1 here. Now, you have to use this row where you have made 1 in order to make zeros below this 1. You cannot use any other row. You got my point?
Yes, sir, I got you.
Okay, so we are...
So for the first row, what will be used? Because in the first row, the first entry needs to be 1. So what will be used for that? यहाँ पे तो हमें वैसे ही मिल गया. लेकिन अगर ना
you have to divide it with the same constant, whatever you have at that entry. You can make it 1. You got my point? अगर यहाँ पे, for example, 3 है, तो आप first row को 3 से multiply, 1 by 3 से multiply कर दें, you'll definitely get 1 here. That operation is allowed, ना? So, जिस रो में आपने 1 बनाया ना पहले, उसी 1 को यूज करना है in order to make below it 0, below zeros. अब आपने पहली रो में बनाया यहाँ पे, इसके नीचे 0 बनाने के लिए आपने सिर्फ यही रो यूज करनी है, कोई और रो यूज नहीं करनी है आपने. ठीक है?
So sir, are we like shifting column by column? Like first we were dealing with the first column and now we are dealing with the second one.
Second and then third and then fourth and then fifth and so on. Okay, we'll convert this matrix column wise. We'll move column wise. Okay?
Okay, sir. Okay, sir.
Otherwise, again, I'll explain you later on. That's why I'm not raising them. Now we are using this one, this one, in order to make zeros below it. So this one is basically, in fact, in the second row. That's why you are using second row here in order to make 0 below this one. I hope you get it.
Yes, sir.
Now, the first row will remain same. You just write it in the similar way. 0. Second will remain same. And third row will be changed. Now, what you are going to do, -3 से multiply करें यहाँ पे तो already 0 है, यहाँ पे 0 होगा, यहाँ पे 0 आ जाएगा. Okay? Now you are going to multiply this thing with -3 and subtract from here. So it will be an entry -11 plus 21 by 2. You okay, na?
Yes, sir, which is -1/2.
So which is minus, you get here, -1/2. Okay? And the last entry will be -27. यहाँ पे ये वाली entry जो होगी, ये क्या होगी? -27 plus 51 by 2. ठीक है?
So ये
-3/2 आ जाएगा यहाँ पे. ठीक है? So you get -3 by 2. Now, next thing, what you do here, in the next step, you try to make this entry 1, the last one, in the third column now. You can see that the ones are basically going into the diagonal. पहले हमने यहाँ पे 1 बनाया, 0 बनाया, फिर हमने यहाँ पे 1 बनाया, फिर 0. फिर हम कहाँ जाएंगे? नेक्स्ट कॉलम में, यहाँ पे 1 बनाएंगे, उसके नीचे 0. नीचे 0 नहीं है, तो we don't need to go further. We just make it 1. How to make this thing 1? Step
multiplying with negative
5 में आ जाएगा ये, या 4 है, 5 है. So what you do here, you just multiply -2 to R3. Okay? So what do you get here? 1, 1, 2, 9, 0, 1, -7 by 2, -17 by 2, and then 0, 0, 1, or 3. You get this?
Yes, sir.
Now, the corresponding linear system can be written as. अब देखिए हमने पहले शुरू में लीनियर सिस्टम से ऑगमेंटेड मैट्रिक्स लिखा था. अब हम इस ऑगमेंटेड मैट्रिक्स से दोबारा लीनियर सिस्टम लिखने लगे. पहली इक्वेशन क्या होगी? पहली इक्वेशन क्या होगी? x plus y plus 2z is equal to 9, and then y minus 7 by 2, 7 by 2 z is equal to minus 17 by 2, and then z is equal to 3.
Sir, if I may.
जी जी.
स्टेप 5 की सर मेरे ख्याल से तो इतनी ज़रूरत नहीं है क्योंकि ऑलरेडी एक वेरिएबल आपके पास आ गया है, तो व्हाई इज देयर नीड फॉर स्टेप 5? तो आपने सिंपल रीअरेंज नहीं करना.
You have to go to the end of the scheme, the procedure. You don't need to make one there. In fact, technically, you can, after writing backwards that linear system, you can solve for z from here. And then you can put it backward here. In the second equation, you get y. And then after getting the values of y and z, you put in the first equation, you'll get the value of x.
So, sir, technically, we are just doing this up in order that whenever we reverse our this augmented matrix into our linear system, we already have one solution, and we can then add that into another one to find another one.
Yes.
Okay. Okay.
This is how. Ji beta bolo.
So basically, we're making the main diagonal is equal to 1, and all the values below the main diagonal is equal to 0.
Yes. Yes. Why we are doing so? We are basically eliminating variables in that linear system so that we can solve it by using backward substitution. Now, here we can use backward substitution. Backward substitution is what? You have the value of z. You can substitute it back in the second equation. You get the value of y. And then you have two values of y and z. Then you can substitute the values of y and z in equation 1 in order to get the value of x. This is called backward substitution. Okay. Now you have z is equal to 3. Put it in the second equation. Y minus 7 by 3 times 3. 7 by 2 times 3 is equal to minus 17 by 2. Okay, now solve it and give me the value of y.
Y is equal to 2.
Y is equal to 2. Now you have z is equal to 3, y is equal to 2, put them in equation 1 and get the value of x. So you get here y plus 1, 2 sir. Plus 2 times minus 3 is equal to 9. So x is what? 1.
1, sir.
Okay, now you get all the values of x, y, and z easily. Whereas, it is difficult to solve that linear system, original linear system, by using simultaneous method. What we have done here, we are doing the same thing. Nothing has been changed. We have written that original linear system into a matrix form, and then basically we are doing the same thing which we basically do in order to solve equations simultaneously. Nothing has been changed. Now we have devised a proper procedure of doing it. Any question? If there is no question, let me repeat that procedure. सबसे पहले क्या करना है? पहली एंट्री को 1 बनाना है, फिर उसके नीचे 0. Let me write it here. Whatever the order of matrix is, you make the first entry 1, 0 below it. Every entry below that 1 should be 0. Okay. For example, we have 0, 0, 0, and then 0 here. या इसको थोड़ा सा खुला करते हैं. Let me 1, 0, 0, 0, 0. ठीक है. Next स्टेप में आपने क्या करना है? सेकंड कॉलम में यहाँ पे 1 बनाना है, फिर उसके नीचे सारी एंट्री 0 होनी चाहिए. ठीक है, नेक्स्ट यहाँ पे 1 बनेगा, फिर सारी एंट्रीज 0, फिर नेक्स्ट 1, फिर 0, फिर यहाँ पे 1, फिर इसके नीचे कुछ भी नहीं है, तो बाकी सारी एंट्रीज वॉट एवर दे आर यू कैन हैंडल देम बाय यूजिंग बैकवर्ड सब्स्टिट्यूशन. ओके, this is how we are going to convert the original linear system into, you have to write it first into augmented matrix, and then you have to reduce that augmented matrix into this form. And this is called Echelon form of a matrix. Echelon. Okay. Echelon form of a matrix. So you have to convert, you have to reduce that augmented matrix into echelon form, and then you use backward substitution in order to get the values of the desired unknowns, x, y, z, x1, x2, x3, x4, x5, whatever the number of variables are there in that linear system, whatever the order is. Okay? I hope you get it. Now, echelon form has certain properties. It's not always necessary that you get 1 here. Okay? Let me explain you the properties of echelon form. Properties. Okay. First property क्या है? First non-zero entry in any row of a matrix should be equal to 1. This is the first property of that of any echelon form. First non-zero entry in any row or in each row आप कह दें, ठीक है? In any row of a matrix should be equal to 1. आप देख सकते हैं कि फर्स्ट रो में पहली नॉन जीरो एंट्री 1 है, सेकंड रो में पहली नॉन जीरो एंट्री 1 है, थर्ड रो में पहली नॉन जीरो एंट्री 1 है. In each row you can see that the first non-zero entry is 1. You got it? The second,
so 0 is not considered.
G. 0 is not considered. First non-zero entry should be 1. Okay. लिखा हुआ है ना मैंने? First non-zero entry in any row of a matrix should be equal to 1. This is the first property of echelon form. ठीक है? The second thing is in any successive row in any successive row the first non-zero entry which is 1 basically, that is 1, should be on the right hand side. Yeah, right hand side, not right hand side. On the right of the first non-zero entry of previous row or above row आप कह सकते हैं, above row.
So we
now what is this? In each successive row, the first non-zero entry should be on the right of the first non-zero entry of the above row. ठीक है? ये इसके right पे है ना? This is on the right of the previous first non-zero entry. This is on the right of the first non-zero entry of the previous row. This is again, and so on. In each successive row, the first non-zero entry should be on the right of the first non-zero entry of the above row. Okay? This is the second property of the Echelon form. The third property is, let me write it here. All entries in any column below 1 should be 0. Okay. That first non-zero entry जो है, below first non-zero entry आप वो कह दें, below first non-zero entry which is 1, first non-zero entry which is basically that is 1. Okay, they should be 0. So अभी हमने ये जो ऊपर मैट्रिक्स लिखा है, क्या ये तीनों प्रॉपर्टीज को सेटिस्फाई करता है? Does it satisfy all the three properties which we have written for the Echelon form?
Yes, sir.
So if any matrix, if it satisfies all these three properties, then we call that this matrix is in the Echelon form, or any other matrix has been converted into Echelon form.
Sir, so any matrix that doesn't have, look, we have made these entries 1 so that we can solve it by reverse substitution. So if, for example, we had any other number on the main diagonal, it'll still be in echelon form?
Yes. In echelon form, it is not always mandatory to make the diagonal entries 1. There could be other than 1 as well. There is a basically confusion in books. Some books say that you must have to make 1 in the diagonal entry in order to get the Echelon form. Okay. Some books say that it is not necessary that you get 1 as a first non-zero entry. It could be anything. But in that case, making 0 below that entry will be difficult. So I would prefer that you people make 1 in the diagonal entries. It will basically make you easy in order to get zeros below this thing. Okay? और किसी भी कॉलम में किसी नॉन-जीरो फर्स्ट नॉन-जीरो एंट्री में अगर आपसे उससे नीचे 0 बनाना है, 1 से नीचे 0 बनाना है, तो you can use only that one, not any other one. Even if there exist some ones in the diagonal entries. अगर आपने इस कॉलम में इस 1 के नीचे 0 बनाना है तो you use only this row. Okay? अगर इसमें बनाने हैं तो सिर्फ इसको यूज करें, अदरवाइज आपके ये जो पिछले 0 है ना ये खराब हो जाएंगे. You can try it. Okay? अगर आपने यहाँ पे 1 बनाया, 1 है, इसके नीचे 0 बनाना है तो सिर्फ इसी रो को यूज करें. अगर आप इसको या इसको यूज करेंगे तो प्रीवियस आपके जो जीरोस हैं वो दोबारा नॉन जीरो हो जाएंगे और एक नेवर एंडिंग प्रोसेस चल पड़ेगा. आप दोबारा उनको 0 बनाएंगे, फिर गलती करेंगे, फिर वो नॉन जीरो हो जाएंगे. इसलिए you have to use the proper procedure and not any other procedure. I hope you get it. Now I am going to change a little bit here in the matrix, and I would ask you whether it is in the Echelon form or not. Is this matrix in the Echelon form?
Yes, sir.
No, sir.
Who is saying no? Tell me why.
No, sir.
Who is saying no?
Sir, I'm saying no. Because in second row, the first non-zero entry is not just after the first non-zero entry of first row.
When did I say that it is not possible?
Sorry,
is there anything like that in these three properties? I have written that in the next successive. No, let me finish with him. Now, in any of these three properties, is this written somewhere? That this next one in the next row, the one should be immediately on the right hand side of the previous row.
Yeah, it is in the second point of few properties.
Second property में मैंने कहाँ पे लिखा है कि ये one यहाँ पे होना चाहिए? मैंने क्या लिखा है? In any successive row, the first non-zero entry, which is 1 basically, should be on the right of the first non-zero entry in the previous row, in the above row. तो ये तो ठीक है. ये वाली जो 1 है, ये उसके right पे है या नहीं?
Yeah, it is.
Right है ना?
Yes.
तो second property तो violate नहीं हो रही. Then what is the problem? Why this matrix is not in the echelon form? Tell me.
Can I answer? So can I answer?
Let him tell me, please.
Okay.
जी बेटा बोलें.
Sir, in third property, you have written all entries in any column below first non-zero entry should be 0. So in third column, the 1 is below the first non-zero entry.
All entries in any column below first non-zero entry. आप कोई भी देख लो. क्या होना चाहिए? यहाँ पे ये कॉलम है, 1 से नीचे सारे 0 हैं. यहाँ पे ये कॉलम है जिसमें 1 है, इसमें सारे नीचे 0 हैं, इसमें 1 है, इसमें सारे नीचे 0 हैं. तो क्या प्रॉब्लम है इसमें? थर्ड प्रॉब्लम
नहीं है. थर्ड कॉलम में वो जो आपने स्टैटिक बनाया हुआ है वो क्या है?
कौन सा वाला? ये वाला या ये वाला?
थर्ड कॉलम में जो ऊपर स्टैटिक है.
ऊपर तो उसके नीचे 0 होना चाहिए ना. ऊपर तो हमने नहीं कहा कि 0. स्टैटिक कोई भी एंट्री है बेसिकली. स्टैटिक 2 3 5 कुछ भी हो सकता है.
तो वो भी तो नॉन जीरो एंट्री है ना
बेटा. मैंने बिलो कहा है ना. किसी भी कॉलम में जिसमें 1 है, किसी भी कॉलम में जिसमें 1 है, उसके नीचे वाली सारी एंट्री 0 होनी चाहिए. आप किसी भी कॉलम में देखें 1 है, उसमें उससे नीचे वाली एंट्री सारी 0 हैं या नहीं?
हाँ जी हैं.
तो फिर तीसरी प्रॉपर्टी में भी कोई प्रॉब्लम नहीं है. ठीक है. आप
ओके
ठीक है. इन आ कॉलम कर दें. इन आ कॉलम having 1 in a column having 1 जो कि फर्स्ट नॉन जीरो एंट्री है रो में. किसी भी कॉलम में जिसमें 1 है, जिसमें 1 है ना, इसके नीचे सारे 0 हैं. इसमें 1 है, इसके सारे नीचे 0 हैं. इसके 1 है, यहाँ पे नीचे सारे 0 हैं. कोई भी प्रॉपर्टी यहाँ पे वायलेट नहीं हो रही. ये मैट्रिक्स जो है ये एचेलॉन फॉर्म में. हाँ बताएं आप. द अदर गाय हु वांटेड टू टेल मी.
So this matrix is in echelon form, and most importantly, diagonal is also like being formed. That would be another property of this echelon form of a matrix.
The second thing, please repeat it.
Sir, you refer to a diagonal formation for diagonal. So I'm saying it could be the fourth property.
No, it's not necessary that all the diagonal entries should be 1. ठीक है. It's not exactly the diagonal. वो पहली एग्जांपल थी, इसलिए मैंने आपको समझाने के लिए कह दिया कि 1 जो है वो डायगोनल में जाता है. लेकिन इट्स नॉट नेसेसरी दैट 1 गोज डायगोनली. ठीक है. 1 यहां से यहां पे चला गया, यहां पे आ गया. सो इट्स नॉट एग्जैक्टली द डायगोनल. इट कुड बी लाइक दिस एज वेल. लेट मी डू इट in this way. 1 0 1. This here. This matrix is still in the echelon form. It satisfies all these 3 properties.
Okay.
So it's not necessary that you always get 1 in a diagonal. ये कुछ different भी हो सकता है.
ओके सर,
ठीक है। लेकिन ये तीनों प्रॉपर्टीज आपने ध्यान में रखनी है कि ये तीनों प्रॉपर्टीज सेटिस्फाई होनी चाहिए। एनी क्वेश्चन?
Yes,
जी
sir.
जी बोले।
Sir, I remember a property from somewhere which had which said that the number of zeros in a successive row must not be equal to or greater than the previous row.
No, it's not true.
Oh, okay.
It's not true. It's not necessary. But the simple thing, you can imagine that why do we need these echelon forms or echelon basically कहते हैं. Why do we need these echelon forms? We try to convert the augmented matrix into echelon form, and then we can use backward substitution in order to solve that original linear system. And the original linear system, the corresponding augmented matrix, and this augmented matrix, they are equivalent. Why? Because I told you in the start of the lecture that these are equivalent systems. After applying these row operations or equation operations, they do not change the solution of the original linear system. Now, the linear system which we can write corresponding to this augmented matrix, which has been converted into echelon form, that linear system would definitely have the same solution as the original linear system. So
सर
these
ऐसा क्यों होता है?
जी
सर ये मतलब ऐसा क्यों होता है कि रो ऑपरेशन करने से वो सोल्यूशन ही चेंज होता है?
देखिए बेटा, सिमिल्टेनियसली जब आपने इंटरमीडिएट में पढ़ा होगा, दो इक्वेशंस को सिमिल्टेनियसली कैसे सॉल्व करते हैं इन ऑर्डर टू गेट द सॉल्यूशन। आप किसी एक कोफिशिएंट को क्या करते हैं, जीरो कर देते हैं किसी एक इक्वेशन में, यही करते हैं ना
जी सर,
और दूसरे वेरिएबल की वैल्यू फाइंड कर लेते हैं। तो जो ऑपरेशंस आप लगा रहे हैं उससे उस पे पूरी इक्वेशन पे कोई इफेक्ट नहीं पड़ेगा। मसलन पहला ऑपरेशन क्या है कि दो इक्वेशंस को आप इंटरचेंज कर लें, पहली को दूसरे पे और दूसरी को पहले पे रख दें, तो फर्क तो नहीं पड़ेगा ना उस पे लीनियर सिस्टम पे।
नहीं सर।
दूसरा ऑपरेशन क्या है कि आप पूरी एक इक्वेशन को किसी एक कांस्टेंट से मल्टीप्लाई कर दें। डज इट चेंज एनीथिंग इन दैट इक्वेशन? अगर 2 = 2 है तो 4 = 4 है, आप दोनों तरफ 2 से मल्टीप्लाई कर दें, इट डजंट चेंज एनीथिंग। ठीक है, इसी तरह जो तीसरा ऑपरेशन
अगर करें,
कॉलम ऑपरेशन अभी नहीं करने आपने, सिर्फ रो ऑपरेशंस होंगे। एचलन फॉर्म में सिर्फ रो ऑपरेशंस अलाउड हैं, कॉलम ऑपरेशंस अलाउड नहीं है, क्योंकि कॉलम में चेंज होगा, लीनियर सिस्टम का सॉल्यूशन चेंज हो जाएगा। क्यों? आप देखिए किसी एक कॉलम को यहां पे, लेट्स गेट बैक टू द बोर्ड 1, यहां पे ये जो लीनियर सिस्टम है, अगर आप किसी एक कॉलम को मल्टीप्लाई कर दें, इट मींस यू आर मल्टीप्लाइंग ओनली this portion of your linear system with some constant. This will definitely change the solution of your linear system, because you cannot do that कि आप किसी एक इक्वेशन में सेंटर वाले वेरिएबल को किसी कांस्टेंट से मल्टीप्लाई कर दें। इट इज नॉट अलाउड। आप पूरी इक्वेशन को दोनों साइड्स पे किसी कांस्टेंट से मल्टीप्लाई कर दें, इट इज अलाउड इन मैथमेटिक्स, बट दैट इज नॉट अलाउड व्हिच यू आर टॉकिंग अबाउट।
ठीक है, थैंक
यू। आई होप यू गेट इट। I hope you get it.
समझ आ गई।
And any linear system, if it is converted into echelon form and then solved, this method is called Gaussian Elimination Method. Okay? Remember it. I'll write it here somewhere. Let me write it. So the method which we use in order to solve any matrix after converting it into echelon form, this method is called Gauss elimination method या Gaussian elimination method. Gaussian elimination. What we are eliminating here? Basically, we are eliminating the variables here. So that is why it is called elimination method. And Gauss inverted it. Gauss, basically a mathematician who gave this procedure or method. That's why it is called Gauss elimination method or Gaussian elimination. I hope you get it. If you have any question, you can ask me. Let's have some other example.
Sir, the process of making this augmented matrix in the form of this Echelon form of a matrix, this and reversing this up and like finding out the solutions. This entire thing is called Gaussian elimination method.
Yes.
So this entire step, or like it's a particular pertinent to a particular step, or this entire thing starting from the top?
Entire thing, yes. From the linear system, you write augmented matrix, you converted it into Echelon form, and then used backward substitution and get the solution. This whole procedure is called Gaussian elimination method.
Okay, sir. Thank you.
Okay. Let me take some other examples so that you can understand it better. In this case, in the first example, you got a unique solution. Okay, you got a unique solution. Now I'm going to change it a little bit, this linear system. Here we have 2x plus 2y plus 4z is equal to 18. Okay, so in the augmented matrix, what do we get here? We get 2, 2, 4, 18. Okay, now again, what we do, we try to make zeros these things. ठीक है, यहाँ पे जीरो आ जाएगा, ठीक है, बाकी एंट्रीज तो वही रहेंगी. I'm going to write directly the Echelon form of this matrix. Okay, the resulting Echelon form. What did we obtain here previously? Let me see it. So it was basically 1, 1, 2, 9, 0, 1, minus 7 by 2, and then minus 17 by 2. And then you get 0, 0, 0, 0 here. Okay? This will be the Echelon form. Finally, after converting this augmented matrix into Echelon form. Is this matrix is in the Echelon form? Can anybody tell me?
No, sir, it's not. It's not.
Why?
It is. So because it's not if you look at the third column, it's not following up that one thing.
It doesn't matter. देखिए, अगर नीचे वाली रो पूरी 0 हो गई है,
okay,
तो यहाँ पे कॉलम में 1 है ना, इसके नीचे 0 है, बाकी आगे 1 है ही नहीं, सारे 0 हो गए. It doesn't matter. ठीक है, अगर 1 राइट हैंड साइड पे होना चाहिए, अगर नहीं है तो पूरी रो 0 हो गई. It doesn't matter.
ठीक हो गया सर.
It is still in the Echelon form. जैसे कि मैंने वो प्रीवियस एग्जांपल आपको दी थी, जिसमें नीचे वाली 2 रोज मैंने 0 लिख दी थी, तो राइट हैंड साइड पे 1 होना चाहिए, अगर है तो. अगर नहीं है तो इट डजंट मैटर, पूरी रो बेशक 0 हो जाए.
सर लेकिन अब आप सॉल्यूशन नहीं निकाल सकते ना.
हाँ, यही तो प्रॉब्लम आपसे डिस्कस करना है मैंने, कि क्यों प्रॉब्लम है, यहाँ पे क्या प्रॉब्लम है. अब देखिए, you have to write back that corresponding linear system. क्या होगा? X plus y plus 2z is equal to 9, and then y minus 7 by 2 is equal to minus 17 by 2. बस तीसरी में आपके पास इक्वेशन ही नहीं है. You are unable to find the value of z here.
Sir, it should be negative 7 over 2z.
Yes, it is z.
So what we can do it like we can make y that variable in that input that in the first equation.
Let z is equal to t, where t is some free variable. In this case, basically your 2 planes are on the top of each other. That's why the equation of the third plane has been vanished. If you notice that, I have written the third equation as a constant multiple of first equation. If you multiply first equation by 2, you get the third equation. If this equation is a constant multiple of first equation, then in Echelon form, the third row must be converted into a 0 row. It should have all the 0 entries. Why? Because 2 planes are basically on the top of each other, and the third plane is intersecting them. So what is the region of intersection do you get here? It's a straight line. So you must get infinite many solutions. In order to get infinite many solutions, you must have a free variable in that solution. Okay? You got my point? Now, here you have two equations and three unknowns. One unknown should be set as a free variable in order to get the solution. And the solution will be infinite many solutions. So I hope you get it now. We introduce z is equal to t, where is z is a free variable, t is a parameter which belongs to r. Now, by inserting z is equal to t here, you can get the value of y in terms of t. And then after getting the values of y and z in terms of t, you can insert back them into equation 1, and you can find the value of x as well in terms of t. So all the three variables now have been found in terms of t. Because t is a parameter, so we must have infinite many solutions by changing the values of t.
Sir, if the point of intersection is a line, why can we not find the equation of that line and use that as our answer?
I'm going to find equation of that line. See it. Now, if you have z is equal to t, then inserting it back into the second equation, you get what? Y is equal to minus 17 by 2 plus 7 by 2t. You get this? Now, what is the value of x? You are going to insert back z and the value of y into first equation. Let me write it somewhere on this board. It is x plus y plus 2z is equal to 9. So z is equal to t and y is equal to what? Minus 17 by 2 plus 7 by 2t. So you can write it, put it back there in the first equation. X is equal to 9 minus y. So 9 minus y is 17 by 2 minus plus हो जाएगा यहाँ पे 17 by 2t आ गया, फिर plus 2z means t. ये आ गया. अब आप इसको simplify करें. What do you get here? 18 and 17.
ये minus
35.
2t नहीं होगा.
35 by 2. हाँ?
ये minus 2t नहीं होगा.
minus 2t होगा. Thank you. So अब इसको अगर आप solve करें तो 35 by 2 minus 4 11 by 2t. ये आ गया. ठीक है? You got my point? Now, you can write the solution x, y, z in the vector form as what? Your x is what? 35 by 2 minus 11 by 2t. And y is what? It is minus 17 by 2 and minus 2t and then t. ठीक है? अब यहाँ पे इसको हम लिख सकते हैं 0 plus t. Now you try to separate the constant vectors and the vector with the values of t. So you can write here 35 by 2 minus 17 by 2 and then 0 plus t times minus 11 by 2 minus 2 and then 1. So
7 by 2 नहीं होगा second row में.
Second row में हाँ
मतलब plus
नहीं
हाँ 7 by 2.
यहाँ पे 7 by 2 था. हाँ ठीक है. 7 by 2 है. Plus 7 by 2 है. यहाँ पे plus 7 by 2 आ जाएगा. ठीक है. Thank you. Now what is this now? Where t belongs to r. It's a parametric equation of a straight line in 3D. It's what? It's a parametric form of the equation of a straight line in our cube. You got my point?
Yes, sir.
You know it? Have you already studied straight lines in 3D?
No, sir.
Basically, what is the form of an equation of a straight line in 1D? 1D में क्या होती है equation of a line? Y is equal to
mx plus c.
mx plus c.
Or it could have been y minus y, y
not
1.
If we call it as an x vector, this is what? This is c vector, and we have t here, and this one is maybe
d vector.
x. Sorry, कोई b कह दें या कुछ भी कह दें. A vector. Now, what is this? This is exactly same as x vector is equal to t times a vector, plus c vector. So it's basically equation of a straight line in 3D, parametric form of equation of a straight line in 3D. Where, what is this? This is your parameter. This is your slope. Sorry, not this one. This
Sir,
is no, A is your slope. A is the slope. Okay? Slope or gradient of that equation of a line.
Sir, but how can a vector be a slope? Like I'm giving a vector 2, 3, 4. How can that be a slope?
देखिए आपके पास अगर 2D है तो आपके पास इंडिपेंडेंट वेरिएबल कितना है x1, ठीक है, y आपका डिपेंडेंट वेरिएबल है. But when you are in space in 3D, you have three components. You have a component of x, you have component of y, you have component of z. So these are basically components here. It's an x component of that equation. This is y component of that equation of a line, and this is z component of that equation of a line.
Sir, but even in 2D, I don't say that my gradient is 2, 1. I say my gradient is 2 or 1 or one number. Even in 2D.
अगर आपके पास 2D है और आपके पास infinite many solutions हैं, if two lines are on the top of each other, तो आप क्या करते हैं, मसलन x plus y is equal to maybe 2 है, तो यहाँ पे आपके पास एक इक्वेशन है. You need to solve them simultaneously. आप क्या करते हो, y को आप t लेते हो, free variable, t belongs to r. अब आपने solution लिखना है, solution x y इस फॉर्म में लिखेंगे आप, x component and y component. x आपका क्या है, t यहाँ पे पुट करें तो ये क्या आ जाएगा, 2 minus t, ठीक है, और y क्या आके आपका t है. So you can separate it and write it 2 0 plus t times minus 1 1. So this is basically an equation of a straight line, and it is basically the parametric form of equation of a straight line in 2D. So parametric form is something different. This is the equation of a straight line, this one which we have written in the parametric form in 2D.
Okay, sir. So does this particular equation which you have just written right now, does it mean that minus 1 1 is my gradient for this x plus y is equal to 2?
This is your gradient of that equation of a straight line, and this is your y-intercept.
Okay, sir. Thank you.
Yeah. Even in 2D, you can write the equation of a straight line in a parametric form. Now, this is your normal form in Cartesian coordinates, in xy coordinates, and this is the form of the same, exactly same equation of a straight line in the parametric form. So what we have written here, it is in 3x3 system, this is basically equation of a straight line in 3 dimension in parametric form. I hope you get it.
Yes, sir.
Any question?
Sir.
Ji beta.
Sir, every matrix has its own unique echelon form. यानी कि एक ही मैट्रिक्स से 2-3 बन सकती हैं फॉर्म्स.
एचलन फॉर्म अगर बनेगी ना तो उसमें देखें, अगर आप यही एग्जैक्टली ये वाला प्रोसीजर फॉलो करेंगे ना जो मैंने बताया, तो आप सबकी तक सेम बनेंगी. ठीक है, ये नहीं हो सकता कि किसी की कोई कुछ एचलन फॉर्म बन रही हो, किसी की कुछ बन रही हो. इट इज नॉट पॉसिबल. अगर आप प्रोसीजर थोड़ा सा चेंज करेंगे तो अगर आप फॉर एग्जाम्पल अगर आप हर डायगोनल में 1 नहीं बनाते, उसको नॉन 1 ही रहने देते हैं, बिकॉज इट इज अनदर फॉर्म ऑफ एचलन फॉर्म. आई टोल्ड यू अर्लियर. तो उसमें फिर थोड़ी सी एचलन फॉर्म डिफरेंट आएगी. मींस डायगोनल में नॉन जीरो एंट्रीज होंगी, लेकिन जो उसके नीचे जीरोज होंगे या एचलन फॉर्म के जो बिलो दोज नॉन जीरो एंट्रीज के जो जीरो होंगे वो एग्जैक्टली सेम होंगे. ठीक है,
ठीक है सर. सर दूसरा वो मुझे आपके वो क्लास लिंक के ईमेल्स नहीं आते.
क्यों बेटा?
सर मैं आपके सेक्शन में एनरोल्ड तो हूँ, लेकिन मुझे ईमेल नहीं आता. मतलब इसके
जस्ट राइट एन ईमेल थ्रू आरओ. यू जस्ट राइट एन ईमेल थ्रू आरओ.
ठीक है सर. सर वैसे मैंने आपको भी लिख दी है, मतलब